Hello, folks. So this is a quick little demonstration to just kind of give you a feel for what AC does in the circuit. Very quickly, if you'll think back to our discussion of how speakers work, if you remember what you have with a speaker is you have a cone. The cone is fixed out here at its edge. Cone comes back. There's a coil that comes out, and then a fixed magnet. Actually, they're usually reversed, but for simplicity, I'm doing it this way. The whole idea is that when the current comes in, going in one particular direction, it ends up generating a magnetic field as the current goes through the coil, and maybe makes this a north pole. And when that happens, this north pole is repulsed by this north pole, and the cone flexes outward. When the polarity of the power source changes and the current changes direction, now the direction of the magnetic field down the axis of the coil shifts, and so now you get an attraction between the two, and now the coil pulls back. And so as you go through the cycles, what the cone does is it pushes out and then pulls back, and then pushes out and then pulls back, and it does it to the frequency of the signal that's being pulled in. So what I have here is a speaker. I have a light bulb, just so you can actually see the current flowing. And again, this is AC. And this is a function generator. Sine wave generators, minor side point, sine wave generators only work between 20 cycles per second and 20,000 cycles per second. So for those of you in my honors physics class and Ms. Dunham's honors physics class, you are going to end up being asked to do a Google form questionnaire. One of the questions is going to be, why do you suppose that is? So I'm just going to let you think about that. This function generator, on the other hand, will actually go down to like a half cycle per second, which is what it's set on right now. So I'm going to go ahead and I'm going to bring the intensity up. And what you're going to see is that you're going to start getting an output on the light. So here's the light blinking away merrily. I hope you can see that. And if you look closely, you can also see that the speaker is going in and out and in and out. And again, I will try to bring the intensity up so you can see. Okay. Now, if I change the frequency, and one other minor side point, and once again, you're going to be asked to explain why this is on this little Google form thing. You will notice that the frequency here is now, 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 now. That's the period. Whereas with the speaker, it's now, now, now. They appear to be different frequencies. And so the question is why? So I'm going to let you muse about that. Anyway, if I go ahead and bring the frequency up, so I'm going to start bringing it up. And so right now we're up at 1 cycle per second. And you can see that the blinking is picked up and the pulsating is picked up. I'm going to go ahead and bring it up to 2 cycles per second. Now it's blinking a lot faster. And so basically the rate at which the polarity is changing back and forth, which means the rate at which the electric field in the wires is oscillating back and forth, which means the rate at which the little charge carriers are jiggling back and forth. Doing it at 2 cycles per second now, you can see it happening. This guy is pulsating faster. This guy is blinking faster. If I go ahead and bring this up to 3 cycles per second, there you see what's going on. There's 5 cycles per second. There's like 10 cycles per second. And you'll see that this is starting to look like just regular old light, the kind you're used to. And this is actually pulsating to the point where you can kind of see it, but it's starting to get kind of hard to see. So if I'm going to go ahead and bring this up to 20 cycles per second, now this just looks like light. I mean, it just looks like regular old light, and you can't see the variation, even though it is varying. Interestingly, if you took an incandescent light bulb and you took a little solar cell and plugged it into an oscilloscope so you could see variations in light, you would actually see that the light varies very slightly, because essentially what's happening is that light bulb is turning on, turning off, turning on, turning off, but it's doing it at 60 cycles. And the light isn't completely going away because, you know, the excited atoms are still throwing out photons, even when the current is, the electrons are changing directions as they're coming back. But the point is you can actually see it with a solar cell, which, you know, produces electrical impulses due to light coming in. The light intensity actually does fluctuate, and you can see it. In this particular case, you can't see, well, I can see it, but you can't. If you listen, though, I don't know if you can hear that, but it's got this very gentle little patter up against my finger. And then if I go ahead and just keep bringing the frequency up, it's going to get higher and higher and higher. Now, an interesting thing is happening. You will notice the intensity of the light is going down here. And we're going to talk about why that might be the case a little bit later. But in this particular case, this thing is just going wild. Okay. Anyway, so we wanted you to be able to see AC in action. Here is AC in action.